This is the part 2 of module 2. So we are to cover here basic device configuration, and let's start. First thing to assign in our network device is a device name or host name, the identity of our device. It is a requirement to assign a unique host name or device name to our device. Guidelines, it should start with a letter, no spaces. Uh, you use letter, digits, or dashes, and the number of characters should be less than 64. To assign the host name, we go to, as expected, we are in the user mode. We type enable to go to the privilege. Okay, enable, and then we type configure terminal to go to the global configuration mode, because it is in this mode, the global configuration mode, where we assign our host name. So to assign host name, the syntax is host name and then the name of the router. Say Mapua, Makati. Okay, there. Okay. Better to use alias for security purpose for our names, device name to be exact. So next, to set up our passwords, some of the guidelines we need to take note. Password should be more than 8 characters in length. Better to have combination of uppercase and lowercase. Never use same password in all devices. And do not use common words like dictionary words that are easily guessed. In our laboratory setup, better to use Cisco or class as passwords, so they can, because they can easily be remembered if we have this common password set. So, passwords to set in our router, first is to secure the privilege mode. So the syntax there is enable secret. So you should be in the global configuration mode. These passwords are set again in the global configuration mode. So to set the enable secret, the syntax again is enable secret, and then the password, say Cisco. Okay. Take note the value here is Cisco. It's case sensitive. Okay, so like in here I use lowercase. So a lowercase Cisco is different to an uppercase Cisco. Next password to set is the console. To secure the console, the syntax is this one. Okay, I have it here. So line con 0 password, and then the password, say class, and then login. Okay, usually the line console is the first password being asked. I'll type exit for us to simulate this. Exit, exit, there, and enter. And if you notice, there's already a password being asked. That password is the line con 0, the password that we've set in the line con 0, which is in this case is class. So I will type class, CLASS, enter. And if you notice, I have entered the user mode. That indicates that the password works. Okay, the password that I've typed works. If you notice, there are no bullets or asterisks that appear. It's a security feature of the iOS. A trivia, iOS is actually a, it originates, or it was developed from Unix. You know what? Linux is also developed from Unix. Okay, and Unix has this feature we call as a shadow mode, and we call this as a shadow mode. Okay, where when you type the password, it doesn't appear. Okay, even bullets or asterisks do not appear. So next, I will type enable. En is the shortcut for the enable. I'll type en. So this time, the second password being asked is the password we've set in the enable secret. So in this case, it's Cisco. So I will type now Cisco. There. So now I entered privilege mode. Okay. So there. These are the two passwords we have. Line con and the enable secret for the privilege exec mode. Next is the line VTY. This is the password. Line VTY is for the remote access. Again, line VTY is for the remote access. Used to secure remote access. Specifically telnet. Okay? Telnet. So, in order for telnet, this remote access to work, we need to set a password in the line VTY. So to do this, we still have to go at the global configuration mode. The syntax is line VTY 0 space 4, and then password, and then the password, and then login. Okay, Let us try that in our router. So uh, I go to conft to go to the global configuration mode. So again, this is typed in the global configuration mode. Same thing here. So now we type line bty 0 space 4 password, and then the password say remote, and then login. There. Okay. Let me emphasize the meaning of this 04. 04 0 0 space 4. It means there are five logical ports, okay, which indicates that the device, a router like this one, can be uh, accessed by five users simultaneous, okay. There. So that's the use of this one. It means there are five ports. Then, example, I telnet a router. Juan also telnets the router. Maria, Jose, Pedro. And we are five. So we can do that all at the same time. If let's say uh, uh, Jacqueline wants to telnet the router, he is the sixth one who attempts to telnet the router. It will not be possible. The only allowed is only up to 4. Sorry, up to 5. Okay, only 5 sessions. Session 0, session 1, session 2, session 3, and session 4. Usually for routers, we have 5 sessions. For switch, we have 16. 0 to 15 for switches. Okay. We will have an example of this in our live session. So there, I'm done with the remote access. So next is so far we've configured host name and passwords, right? If we want to verify those configured, that we have configured, we can check it through show running config. So again, to display actual or running configuration, the command is show running -config. Okay, I'll type it here, show running -config, and there's an error detected. So let me type question mark. And if you notice, in the list of the commands, there's no show. So usually, that indicates the show command that I type, it is not done here. It is not recognized in that mode. So what we do is we exit. Okay, exit. So I'll type question mark. And if you notice here in the privilege mode, there's a show, right? So usually show commands are done in the privilege exec mode. So I type now show running. I can type tab. Okay, what I type is tab. So it completes the commands. No, he recognized na yung running config. So di-display niya. It displays already the running config. And then I press enter. So there I have set already a host name. If you notice, with the enable secret, there's jumbled characters here. Enable secret is encrypted. Okay, sorry. Enable secret is encrypted. It uses MD5 level of encryption. But for the line console, which is found here at the bottom, for the line console and line VTY, they are not encrypted. They are displayed in plain text. If you want to encrypt all passwords, you type this, service password encryption. So let's do that. I go to conft. This one, no? I have here an error translating. The shortcut for that to suspend is Control-Shift-6. Okay, again, Control-Shift-6. So again, conft, the shortcut for configure terminal, and then press enter. So we type now service password -encryption and enter. Okay, I'll type exit, and then again type show running config. Okay, enter, then space bar. So if you notice, I cannot see the class and the remote that I've set. This is already encrypted. Okay, the line console and the line VTY. It uses a type 7 level of encryption, which is actually not that secured. Okay, there are websites that can crack these encrypted passwords. There. So next is banner. If you want to set a message that usually appears upon login, you may do that through banner. Okay. So to do the banner, we go to the global config and we type banner, MOTD, a character, say a hashtag, and then let's say we type authorized access only, okay, and then close and then enter. There, okay. If I type exit, and there, I have here a my message. No, very important. If you notice, if we enter a system like a Wi-Fi, there are terms and conditions, agreements, guidelines, policy that are being um, given to the user. So in here for the router, we may do that through the banner. Okay. And to save our configuration, the syntax for saving is copy, and then its syntax is source and then destination. So far, what we have configured is saved in a memory called as RAM. Just like our computer has RAM, I suppose everyone is familiar with RAM in our computers. It is where our running applications are stored, like this one, Power Packet Tracer, PowerPoint. It's all active, it's all running, and it's currently saved in the RAM. So our router also has a RAM. Okay. Uh, and initially, my configuration is saved in the RAM. Problem with RAM is it's temporary, right? Temporary. So we need to have a permanent storage. And in our case, for our routers and switches, that is in the NVRAM. So this is the permanent storage of our device. So in order to save our config from the RAM, going to the NVRAM, this is how we do it, ano? So copy the source. The RAM is running config. So we type running config, and the NVRAM in our iOS, it's startup config. So in here we type startup-config. So again, the command to save is copy. It's in the privilege mode, by the way. So it's copy running-config and then startup-config. Okay, and then enter. Destination file name is this one. So it gives us a default file name. We'll use that. Enter, and then it says okay. To verify if it is already saved, we may look into the startup config, and we should be able to see an entry. Enter, and there, if you notice, I have my host name, my enable secret, and then my banner, and then my encrypted passwords for the line console and line VTY. Okay. So again, this is how you save your your configuration file to the NVRAM. Next in my agenda are IP add. Let us have a simple network, no? So I will add a switch. I'll use okay, I will use a switch here. Okay. And then I'll have another PC. This one. So I'd like to connect PC4 to PC5. So I will use a cable. If you were to connect PC to switch, cable to use is this one, straight through. We'll discuss more on these cables in one of the meetings. So we choose fast Ethernet, and we choose any fast Ethernet port here. So again, choose the straight through, choose the fast Ethernet in the PC, and then choose the fast Ethernet port here in the switch. Okay. To connect the switch to the router, choose any fast Ethernet port available in the switch, and then Giga Ethernet in the router. Ethernet is that's our LAN port. There's one chapter we are to discuss Ethernet technology in detail. So now, in order for this to connect, we need to assign IP add on our PC. Okay. So as with our router. So basic concept of the IP add, things to take note. It's 32 bits total. It ranges from 0 to 255. There's no 256, 257. It is 4-dotted decimal in nature. I have an example here. And there are two parts. Network part and then the host part. Okay? So network part should be the same. Host part should be unique. Okay? Example. Let's say I will assign an IP add in PC5 as a 192.168.10.3. And let's say here, the 192 is network, 168 is also a network part, and then 10 is also a network part, while 3 is the host part. So if we were to assign an IP add in PC4, in order for that to connect to PC5. So again, network part should be same. So it should be 192.168.10. Okay? If you do not observe this rule, it will not connect. And then the host part should be unique, say 4 or 5 or 6. Okay? There. Um, Analogy, like our phone, in our mobile number, there is a number that's the same, right? Example for Globe 0917. So that's the network part. And then the last 7 digits are the host part. They should be unique. Okay? There. Okay? Now we assign this IP add to our PC. In the packet tracer, we do it here. We click the PC, and then we go to desktop, and then the IP config. This is where we assign IP add. So again, I will assign 192.168.10.3. An IP add has a pair, body, or we call as a subnet mask. So let's just use the default. We will discuss this further in one of the chapters. Okay. Um, Again, as I mentioned, we also have to assign an IP add in the router. Say, I will assign an IP add in our router as 192.168.10.1. Okay? If we have a router in the network, we assign that IP address in the router here as its default gateway. Okay? So again, let's say this one, the router's interface, let's say we assign an IP add of 192.168.10.1. So again, to assign IP add in our PC, we go to the desktop and then IP config and then go to static, make sure it's in static, and then we assign it here 192.168.10.4. Okay, and then the subnet mask, and then our default gateway is our router, like in this case is 192.168.10.1. There, done. Okay, in order for us to know if these two computers are connecting, we use the test command ping. We ping the IP add. So let's say I'll ping 192.168.10.4. And if there is a reply, it means it's connecting. We will discuss further the concept of the ping in one of the chapters. Say I'll check if it connects to the router, and it says not yet, right? Because we haven't assigned the IP add of this 192.168.10.1 to this interface, right? So if it is not working, this is the message we expect to see. Request timeout. So now we proceed. There's a new version, IPv6. We will discuss this further. Okay. Usually starting Windows Vista, starting Windows Vista, it starts supporting IPv6. Okay. So this is how we configure interface in our router. So we go to. You may also configure the router here by clicking the router. You go to the router and then CLI. Okay. So, router's interface is configured in the global configuration mode. Okay. So, we type conft and then we go to the interface. Like in this interface, I have is Giga Ethernet. So, G is the shortcut. G 0/0. So, its specification is 0/0. I will discuss that in one of the chapters, and then press enter. And then the IP address, and then the IP add 192.168.10.1. And then its subnet mask should be the same as with our computers. If they are in the same network, usually what is expected is they have a common subnet mask. So if you recall, the subnet mask is 255.255.255.0. Okay, there. Okay, so this is how you assign an IP address in a router's interface, and then enter, and then you type no shutdown. No shutdown. There. Okay. There are notifications if an interface goes up. So now let's check if a computer can connect on this interface of the router. So we'll try. So again, we go to the computer, we go to the command prompt, and then we may press arrow up, okay, to check the connection. If you notice, there are color indicators here of the status of the port. And if you notice, a while ago it's orange. If it's orange, it's still not, it's not yet stable. You have to wait until it turns into green. If you don't have that patience to wait, you may click this one, fast forward. Okay, so now it's already green. So press enter, and there's a reply. So meaning this computer now can connect on our router. Okay. Uh, you know what? Our switch, if we were to configure the switch, it's the same. They have the same environment as with the router. It's still iOS. So again, like an conf t, and then say we set host name, say S1, say let's say this is in the first floor, and then we set enable secret, say Cisco, and then line con 0 password, say class, and then login. Type exit for the line VTY 04, password, say remote, and then login. Okay, and then exit. We also have to assign an IP address in our switch. Okay, and this is how we assign IP ad in our switch. Okay, um, we assign IP ad to the VLAN 1. We call this as the SVI, Switch Virtual Interface. We need to assign an IP ad in our switch in order for us to manage our switch, especially remotely, or let's say if we want to connect a monitoring software in our switch. So, to assign an IP ad, we go to that interface, to that logical interface we call as VLAN 1, and then IP address, and then the IP ad we are to assign. Say 192.168.10.5, and then again same subnet mask. Say 255.255.255.0, and then no shutdown. No shut is the shortcut for the no shutdown. And there, okay? Let's see if our computer can connect on the switch. Try to ping, say 10.5, enter. Okay? Again, you may use fast forward, okay, if you don't have that patience. And if you notice, there's already a reply in the 10.5. Again, the purpose of setting up an IP ad in the switch is for, let's say, if we want to access it remotely. Let's try that, telnet, that's the command. Say 192.168.10.5, enter. It asks for the password. This password is the one we set in the line VTY, which is remote, enter. And if you notice now, our computer can access our switch remotely. Example, our switch is on the 100th floor and this PC is on the first floor. No need for the user to go to the 100th floor to access the switch. He can access that remotely. IP ad, as in my example, we configure it manually. We may also configure it through DHCP. It is discussed in cisco2, this DHCP, at assigning IP address automatically in our end devices. Our routers has that ability to act as a DHCP server. Okay, and that ends part 2 of module 2. I hope you learned a lot. So keep safe, and together we learn as one. Thank you.